This is the Integrated Math 1, Semester 1 final review for Chapter 3. I'm on page 1. Question on the number 1 on the front says, use the area model below to answer the following questions about the problem. So you're filling in the missing pieces. To get this x squared, you'd multiply x times x. To get x, you'd multiply 1 times x. 1 times x to get x, and so on. So you're going to fill in all the missing areas for the blank tiles above. That's what I did up here. Part B, label the outer dimensions, distance to find the length and width of your total rectangle. So I got an x plus 3 and an x plus 1. Find the total outside perimeter of the rectangle using your length and width. So I added up everything on the outside. I got 4 x's and 8 units. D, I wrote an equivalence statement to represent the area as a product to equal the sum. So as a product, I did x plus 3 times x plus 1. To get the area as a sum, I had 1x squared. I had 1, 2, 3, 4 x's, and I had 1, 2, 3 units. Question number 2, they're asking you to multiply. So I distributed the 4. 4 times 3x is 12. 4 times 5 is 20. Part B, I distributed the 6. So 2 goes into 6 3 times. 3 times 1x is 3x. 3 goes into 6 twice. 2 times negative 2 is negative 4. Then I used FOIL to multiply for part C. So x times x is x squared. X times 4 is 4x. 2 times x is 2x. 2 times 4 is 8. These two middle terms are like terms. They combine to get 6x. The other two terms stay separate. I used FOIL here again. A times a is a squared. A times 4 is 4a. Negative 4 times a is negative 4a. And negative 4 times positive 4 is negative 16. These two middle terms combined, they're actually opposites. So that term eliminates, and you're left with the a squared minus the 16. Part E, 2x times x is 2x squared. 2x times negative 4 is negative 8x. 3 times x is 3x. And 3 times negative 4 is negative 12. These two middle terms combine to get the negative 5x, and the other two terms stay the same. Turn over to page 2. Up at the top, question number 3A, solve for the unknown variable. So we're going to add 4 to both sides, divide both sides by 2. That gets us to x equals 6. Part B, add 14 to both sides, and then we're going to divide both sides by 5. So we get y equals 2. Question C, we have variables, the same variable on both sides, so I'm going to move them to one side or the other. I'm going to do that by subtracting 2a from both sides. In the same step, I'm also going to subtract 5 from both sides, so we get a equals 12. You can show that as 2 separate steps if you'd like. Part D, we're going to distribute 5 times g is 5g, 5 times 6 is 30, subtract the 30 from both sides, divide both sides by 5, and you get g equals negative 4. Question E, you're going to add 4x to both sides because you have variables on both sides. In the same step, I subtracted 7 from both sides. So on the left, I have 2x. On the right, I have 6. So when we divide both sides by 2, we get x equals 3. For part F, I did my fraction busting by looking for the least common denominator, which was 27. So 3 goes into 27 9 times. 9 times x is 9x. 27 goes into 27 once. So 1 times 9 is 9. And then 12 times 27 is 324. Subtract 9 from both sides, divide both sides by 9, and you get x equals 35. Part G says verify your answer for part C by plugging back into the equation. So for part C up here, we got a 12. So I'm going to plug 3 in here, or 12 in here. So 3 times 12 plus the 5 is equal to 2 times 12 plus the 17. Then I simplified. 3 times 12 is 36, 2 times 12 is 24, 36 plus 5 is 41, and 24 plus 17 is also 41, so it checks out. Question number 4, we're going to translate the triangle PIT up 4 units and 6 left. So I started with the P, I went up 4 units and 6 to the left, called it P prime. Then I went over to I, went up 4 units, left 6, called it I prime, up 4, left 6, called it T prime. Question number 5, reflect triangle across the y-axis and then across the x-axis. So here's your y-axis. I reflected it over here, called the triangle A prime. Then I reflected it across the x-axis down here, and that would be A double prime.